Our next presenter is Greg Harder, who I mentioned was senior regional engineer with the Asphalt Institute. He covers the northeastern part of the U.S. He's going to cover thin lays construction practices.
Well, good afternoon, everyone. Hopefully you can see my screen. As Steve mentioned, I'm the Northeast senior regional engineer for the Asphalt Institute, and I'm very blessed in that I work with a lot of really good engineers, and we cover all of North America. And when Neil had asked me to give a talk on thin lift construction practices, I had never really done that before, but because I work with all these other engineers, we typically share information or share presentations and slides. So I hit the mother load with this one. I actually reached out to our engineers, and Danny Gearhart was part of a webinar. I guess it's been about 3.5 or 4 years now that they put on in conjunction with Ken Hansen from Napa and Mike Heitzman from NCAT, and they did it on behalf of Federal Highway Administration. So for all the presentations I've given, this is probably the one that took the least amount of effort in terms of preparing physically, preparing any slides. So I want to make sure that they get the acknowledgement that those three were really responsible for pretty much everything I'm going to share. Obviously, their webinar that they gave was an hour and a half, believe an hour and a half, maybe 2 hours long. I think it was a total of 85 slides. In the 20 minutes that I have today, obviously I can't cover all that. Wanted to focus it more on the construction practices, so I've eliminated some of the sections, go through a brief introduction, talk a little bit about project selection, surface preparation, talk a little more about construction, and then some of the conclusions that they found. In terms of the introduction, back in 2012 to 2014, I think the project ended. NCAT was contracted by NCHRP to develop a synthesis on thin asphalt concrete overlays, and they surveyed a number of the states. I apologize, I don't know the number of responses, but what they found was, depending on the state agency, what did they consider to be a thin lift asphalt layer? And as you can see by the responses, it went anywhere from 3/4 of an inch up to as much as 2 inches. Generally speaking, while it's not given for the most part, and if you look at the data here, for the most part, state agencies, at least those that responded, consider a thin lift to be that of something that's 1.5 inches or less. The other thing with these materials, they could be a number of different types of mixtures. They could be a dense graded type mixture, super paved type mix, or they could be gap graded like an SMA, or a number of agencies use open graded mixes such as an open graded friction course or porous friction course. They were also asked, where are they used and for what reasons? And some of them are using thin lift overlays as a preservation tool. So they are strategically planning them out, placing them in multiple at different times before they have any loss of serviceability of the road. So trying to extend that and maintain that high service level. So before they're really starting to see any real loss of service. Other agencies are using them where they start to see some deterioration and loss of ride quality, whereas then they'll come in and put a thin lift in. And then other agencies use them in locations where they're trying to cut down on wet weather safety issues, such as hydroplaning, the spray that you get from wet pavements, as well as on a wet pavement at night, some of the glare that you can get from oncoming headlights. So again, they're used for a number of different reasons in a number of different ways. So I want to talk a little bit about project selection. Thin asphalt overlays are really treated as a pavement preservation activity, not really, not in as much adding any structural value to the pavement. Although if it's done early enough, it can add some value. But just like any preservation activity or technique, choosing the right candidate project is really critical. These mixes have been found to be very versatile. They can be used on a wide range of applications in terms of traffic level. Obviously, the materials for the lower volume roads would probably not be the same materials that would be used on, for instance, Interstate 675 in Ohio, where they probably used a polymer modified material. Maybe they weren't using it on the low volume roads. Put in the right application and on the right roadway, good structurally sound pavement, they can perform regardless of traffic level. Now, this table, Danny and Mike and Ken put together, I think it came right out of the synthesis. But nevertheless, you can see all the different types of distresses that we can experience in our roadway. And the way this table is set up, going from left to right, you've got low severity versus high severity on the right. And for each of the distresses, anything in green would suggest that if you have that level of severity for that distress, that roadway could be a good candidate, and that a thin overlay would be effective on that project. Anything in yellow is starting to get marginal, where you might not meet the expectations of performance if you utilize them. And then anything in red is suggesting that that particular project with that type of distress is not appropriate. Now, one of the things that I guess it was mentioned that possibly, that red maybe shouldn't be called not appropriate, but maybe, caution in terms of if you address that type of cracking or that distress, even though it was present, maybe it would be a good candidate. So for instance, if you took the first line and you had an isolated area of high severity fatigue cracking, if you were to remove that material, if the agency was, and to replace it with good sound material and address the issues, then the thin overlay could be a good candidate or a good treatment. Looking at surface preparation, anytime you have any rutting or cracking that's due to failure of the mix or plastic movement of the mix, all of that should be removed. You want to make sure that you remove down and get through all that distressed material and get into a good sound pavement. We all know the benefits of milling through having an improved smoothness, reshaping the cross slopes, and helping to get positive drainage away from the road. Urban areas, we're able to maintain our curb reveal as well as clearances and overhead structures. So we all recognize the benefits of milling and how important it is to remove that distressed material for the thin overlay. You have to make sure when you do mill that you get down into structurally sound surface. This will help to mitigate any of this delamination or the scabbing that takes effect if you don't get down into that sound material. This is problematic when we try to place any kind of a thin overlay over a surface like this. If we have areas that are unlevel or uneven, it's recommended to do some type of a scratch course or a truing and leveling course. Typically, these should be a very small nominal maximum aggregate size mixture, maybe 4.75 or even a sand mix. These are able to fill in those low spots and skim across the high areas. Really try to avoid anything with a large nominal maximum aggregate size for a T&L course. Is absolutely try to stay away from coarse mixes. You want to stay on the finer side of the gradation. In terms of construction of thin lifts, one of the things that you have to really take into consideration is just because it's such a smaller mass of material, it's going to cool much more rapidly. Asphalt is a thermoplastic material, which means as it heats up, it becomes more of a liquid. As it cools down, it becomes more of a solid. And in order to achieve density, we need to have that liquid in a state that we're able to manipulate the mix and push those aggregates together. There's a couple of really neat apps that you can get. One of them is called PaveCool. This is the one we're showing here, but there's also one called MultiCool. I apologize, I forgot one works on an Android device and one works on Apple devices. I believe PaveCool is the Apple device app. They're really neat. You can go in and plug in your current environmental conditions. For instance, in this example, 50-degree air temperature. We're assuming for this example that the surface temperature was plugged in at 50 degrees. Things like the sky, the latitude, the wind speed, the type of mix, the binder grade, lift thickness. In this case, we put in 3 inches and a mixed delivery temperature of 300 degrees Fahrenheit. And then also you can put in preferences as to what you want for a starting and a terminal value for temperature. In other words, in this case, we put in 175 degrees Fahrenheit. So all compaction needs to be done before the mix reaches 175 degrees Fahrenheit. So for this example, under these conditions, placed at 3 inches, we've got 44 minutes to achieve compaction. However, if you consider placing a 1-inch lift and have everything remain the same air temperature, surface temperature, mixed delivery temperature, everything else remaining the same to get to that 175, you now only have 7 minutes. So it's something that you need to consider when placing these thin lifts, that you have to stay on top of your operations and make sure that rollers stay up close to the paver, just because you have such a limited amount of time to achieve density. What complicates this time for compaction is night paving. We see an awful lot of that in the Northeast. Cooler temperatures at night, higher humidity can cause that time for compaction to be reduced even further. One of the other things we often try to recommend is that we try to pave and don't put the material down until the tack has broken. The nighttime paving operations, cooler temperatures can slow that down as well. So again, just something to consider, that in terms of how much you're going to put down in a night. All these things can slow down the productivity. Tack coat itself is, for any overlay, any mix, is critical, but it becomes even more critical for the thin lays. The interface, between that new layer and the old layer is so close to the surface, where you have those shear forces while vehicles are turning and stopping, accelerating. It becomes even more critical that we have a good application of tack coat, not only in terms of the right amount of material, but also good uniform and complete application. Something we see an awful lot of, we lose the tack that gets picked up on the construction vehicles. This is a problem for all lifts. Some agencies have gone to some of these reduced or trackless type tack coats, and many have had very good success with those. But this is an issue not only for thin overlays, but for all overlays, and we want to make sure that we put the tack down and it stays where we put it. Cleaning the material cleaning the roadway before placing the overlay is really critical. Again, milled surfaces have become a really difficult, especially in a lot of our operations in the Northeast, where everything is a mill and fill and open to traffic in the morning. And I know a number of my agencies have been starting to look at and really hoping for, they're going to micro milling, and then they're allowing that milled surface to be open to traffic, sometimes as much as 2 weeks. During that time, they hope for a rainstorm, because that's really the best way to clean that surface. But again, just have to be very aware of the potential for tracking and how important it is to get that good application of tack coat. What are the application rates? Well, what's really important is the residual rate, whether you're using an undiluted or a dilute emulsion. What we're really interested in is what's left after all the water leaves. This came out of our workshop that we had developed for Federal Highway Administration on tack coat. Depending on the surface that you're applying the tack coat to, changes that residual rate. Some surfaces are much thirstier, much more porous, and really can take more or require a higher residual rate than others. If you're paving over a new asphalt surface, you're going to be in that residual rate of 0.02 to 0.045 gallons per square yard. And again, that's residual asphalt. The next column over is the approximate bar rate. So if you have an undiluted emulsion, you're going to, obviously spray a little bit higher rate, because that has some water in it. And then to the far right, if you diluted that 1-to-1. If you're on an existing asphalt surface, obviously that's going to be a little more hungry for asphalt, a little more porous, quite likely. So you're going to typically see higher application rates. The same is true for a milled surface. You got more surface area there. And then Portland cement, somewhere in between a new asphalt and an existing or milled surface. So again, very important that we get enough material down, get the right residual rate, and make sure that it's put down uniformly, both transversely, longitudinally, and that it stays there. Here's something that have to reduce the urge. Because these materials are being put down much thinner, the same amount shows up in a truckload, but each truckload goes a little bit further, and the paving operator tends to work off of production. So they're always trying to get as much down. It's just the nature of our business as they can in a day. And because these materials are so much thinner, so many less pounds per square yard, it really entices or causes the paver operator to really want to go much faster. I actually saw a video. One of our engineers was out on a paving project out in South Dakota, and they were putting down on an interstate a 3/4 or 1 inch overlay, and they actually had the paver running at over 170 feet per minute. Unfortunately, if you don't have sufficient rollers to keep up with it, then you're really shooting yourself in the foot here. So you got to lose the urge to go faster. And really what's going to dictate how many feet per minute you can go with the paver is the number of rollers and can they keep up. And again, this just gets back to the fact that these thin lifts cool so rapidly, and you have a much less time to compact them. A number of agencies, especially for some of the specialty mixes like an SMA or the open graded friction courses, will require the use of a material transfer vehicle. One of the beauties to these is that it will mitigate any segregation, both physical as well as thermal segregation, and really can improve the ride quality because you don't have trucks bumping into the paver, and the paver can run consistently. But again, you have to make sure that your rollers can keep up. Spray pavers, we've all seen ultra thin bonded wearing course and the success that those materials have had over the years. We're starting to see other types of mixes, thin asphalt lifts, being used with those same spray pavers. Consideration should be given by the agency to look at some of the specialized tack materials that are used in these pavers. They've come a long way in terms of the ability to consistently spray material with some of this equipment. So seeing more and more of these being utilized, not only in the thin lift applications, but just in general. In terms of rolling, depending on what your definition of a thin asphalt overlay is, if it's a super paver and SMA, you may be able to use vibratory roller in the vibratory mode. If so, it's typically going to be on a very low amplitude setting. However, for a lot of these mixes, they are just so thin that you'll end up breaking aggregate and really hurting the ride quality, the smoothness. So for most cases with a lot of these thin overlays, especially when you get down less than an inch, typically they're going to use the vibratory roller, but just use it in a static mode. For the open graded friction courses or the porous friction courses, static rollers are typically used. And one of the things you have to be aware of is that you don't want to over roll these materials. These are designed to be very high in air void content just by the nature of the mix and how they want to be able to move water around the tires and cut down on the spray. So don't over compact these. Typically 1 or 2 passes just to really seat that mix into the existing surface is sufficient. So just to try to summarize a little bit, there's no standard definition of what a thin lift is, at least based on the synthesis that was done back in 2014. What they can be used for is to address functional issues, safety issues, and to maintain roadways in all types of traffic conditions as a pavement preservation technique. Project selection, again, is key. And based on the survey results, a number of agencies found that when they placed these thin overlays on structurally sound pavements, they were getting upwards of 10 years of life out of those pavements. Again, these thin asphalt layers can be dense graded, which tends to be the most popular, but they can also be gap graded or the open graded friction courses. Tack coat application, again, very, very important at the right rate, but also has to be consistent, both transversely, longitudinally, and that we make sure the tack coat stays there, that it doesn't get picked up by the construction vehicles. The time for compaction is greatly reduced for these thin layers. So again, have to be aware of that and make sure that the paver doesn't get too far out ahead, gets away from the urge to go too fast. Rolling strategies, again, are typically going to be, for the most part, steel drum rollers in static mode, whether it's the dense graded mixes versus SMAs or open graded friction courses. Some free information that's available. Again, you can download the synthesis 464. You see the link there. And NAPA also has an informational series 135 that you can purchase, or maybe that's a free one. I'm not 100% sure. But and then also FHWA has come up with a checklist for thin hot mix asphalt overlays. So with that, thank you for your attention, and thanks to our members for keeping me employed, and thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.